All right, welcome back to the third video in this series of Unit 1 looking at the introduction to precision ag. So earlier we've looked at, defining precision ag, the history, kind of looking at currently what we have been doing with precision ag or where we're kind of currently set. Now this series, what we're going to look at is kind of some of the issues that we have seen with precision ag. We'll kind of finish up with what some of the more current issues are that we have and what we could see coming here in the future. And then we're going to wrap up with kind of one of the more interesting parts of this unit is kind of the future and looking at some of those, as I've said earlier, is, what is the future of precision ag looking like? And there's, if you look 10 years ago, you never would have found much. Now we can find tons of information on what it is going forward. So kind of begin with looking at the current issues, what we've seen in precision ag. And usually all the time when I ask people, what do you think is what is a big issue with precision ag this day and age? And the number one response I always get, or typically the first response I get, is the cost. And usually that mentality was, well, I can't afford it. And if you look at a typical modern day precision ag system, if I want to put auto steering in a tractor, I'm probably looking at, to get started, I'm probably looking at $7,000 to $8,000 minimum. And there's some farmers that look at that and go, that's a lot of money. It's not worth it. And so, and that kind of, as the industry has evolved, we've gotten better at handling this and trying to put that cost into perspective. And that kind of falls into what the second current issue has been, is how the industry has sold precision ag, how we've sold it. And what we have done now, we've actually gotten to the point where we are proving that precision ag is very viable, it is affordable, and it is cost effective. Which kind of goes back to that whole, I can't afford it. There's numerous cost efficiency models out there, spreadsheets, applications where once you plug it in, and once again, kind of depends on the technology, but a lot of the common precision ag technology that we see out there, whether it's a variable rate system or an auto steering system or a yield monitor, typically we can justify that cost. It's going to pay for itself in less than 2 years. And once you prove that, and that we've proved that, the whole cost thing goes away. So the hardest part with the whole selling it, though, is that we still don't have a lot of qualified technicians or specialists out there, people that are precision ag specialists. And so because of that, we're still having a little bit of a hard time selling it just because there's not enough people out there doing it. So that has been two issues that typically come up. Another one is just the adoption part. And this was earlier on. Once again, it kind of went back to the whole cost and a farmer or producer not knowing exactly what it is. And why I say adopting here is, adopting it into their operation. And so earlier on it was an issue. Now it's not so much. And to kind of show you that, this was a study, and I haven't been able to find anything newer, but this was back in 2011. This came from the USDA through the National Ag Statistics Service. There was a survey that they had done with dealers, and said, okay, how much of this stuff is being adopted in terms of precision ag technologies? What you can see there on the chart, it's kind of interesting, is biotech soybeans. That's the part that came from the USDA. The rest of it came from, it was a study done in 2011. And so the best part is you look at this is biotech soybeans, GMO soybeans, you could see was in 2000 over half of the dealers were saw GMO seeds being used. At that same time though, we didn't have guidance, but we did have what was called light bars, a guidance system. And at that point, it was maybe 25% of the people out there. So half of the people using GMO seeds were utilizing some sort of precision ag. But then when you look at as we move forward is you've seen how light bars and that technology, so light bars, auto steering, auto guidance, you look at auto guidance and how it exploded from 2005 up to 2009. And where they're forecasting it in 2011 is where they saw it was supposed to be at 60%. I would imagine this day and age, if you took a look out on a typical farm, my guess is we're probably 75 to 80% of producers out there are utilizing some sort of precision ag technology. So the adoption thing is not so much an issue anymore, because once again we've gotten through the cost, we've gotten through the selling it, showing the true value of it. So that is, this one has kind of gone away. Another one, and this was a big thing back in the day, was the old dog mentality. Can't teach an old dog new tricks. And I'm the prime example of that. Or in my family farming operation, I was the younger guy that says, hey, I saw GPS, I saw precision ag, and this is something we need to do, Dad. And my dad would, is it really worth it? I'm not so sure. And when we started utilizing it, the first thing my dad says is, this newfangled technology, I don't know how to run it. You take care of it. So that was an issue we've had, because you look at the average age of the American farmer, they're up in the 50s and the 60s. So there is that old dog mentality. But over the years, precision ag has become more user-friendly. What you see there on the screen, and I'll play this video for you, but what you see on the screen there is a modern-day display from Ag Leader, and it is very user-friendly. So if you go back and look at the original monitor that we had in the first video series, the ones that Ag Leader came out with, this is Ag Leader's newest one. It comes in leaps and bounds. So, and the best part is the whole theme for this ad is so simple, your dad can teach you. So watch this quick little video from Ag Leader.
Everything I know about farming, I learned from Dad. He taught me how to work, how to be a good steward of the land, and how to make informed management decisions. One thing I never expected Dad to teach me was how to use precision farming tools. After all, he still owns a flip phone. And yet, there was Dad teaching me how to use our new Ag Leader in-command display. The tablet-like interaction, the split-screen view, row-by-row mapping. Dad even showed me how to use Agfinity to sync our in-command with my tablet, and how to use DisplayCast to sync two in-command displays. Not bad for a guy who still rocks a flip phone. But that's Ag Leader for you. They've been making precision farming simple for 25 years. So simple, Dad can teach you.
Okay, so once again, current issue, the old dog, there's probably some of that still out there, but it has really not so much an issue anymore. Another issue that's kind of been along those same lines is kind of the learning curve. Kind of falls into that old dog mentality. Well, there's a lot of new stuff to learn. I don't think I can learn it. It's just too much to learn and take in. And once again, some of the first technology we saw in precision ag wasn't very user-friendly. So there was a learning curve to it. But this day and age, that learning curve, it's not so steep as what we would see there in that image. Still a little bit of a learning curve, but the analogy I typically give now, it's kind of like learning how to ride a bicycle. The first times you did it, it was kind of wobbly, you weren't so sure of yourself, but as you did it more and more, as you got more comfortable, you got a lot better at it. This is the same thing. So once again, this issue, still an issue out there, but not as bad as what it was earlier on. Probably the biggest thing that we have going forward in terms of issues of what you could see coming up here forward in the near future, and I've kind of titled this data. Precision ag has been around for quite some time now. When you look at yield monitors that have been out for 20 some years, doing things with auto steering, variable rate applications, planning data, we've gathered and collected a lot of data. And so the issue has become with this, we have all this data, what do we do with it? How do we analyze it? We've gotten really good at making really pretty maps, but we really haven't, we're still working on, and this has been the more recent focus is making sense of that data, or having that data starting to interpret what's going on and allowing us to make that more informed decision. So a key part to this data part is the analyzing it and making sense of it, because there's so much of it out there, just making sense of it. Other thing that you could see coming down the line is, in terms of the data, is the ownership of the data. As I've said now for several years, it's probably not a question of if, but when is there going to be a lawsuit when someone is going to sue someone else over data that's been collected. Whether that's a farmer had a yield monitor that had data, now someone else is going to be farming it and wants that data, or thinks they have access to that data, or that data is theirs. Or you put data up there on the cloud, you put it as part of as a large company's data format to put it through their mapping stuff. Who's going to own that data at that point? So, and kind of along with it is we're starting to see a lot more what's called cloud computing, where that data is ending up, we're putting that data out there on the internet. And so, and along with that becomes, how secure is that data? How do I know that my data is not going to be utilized by someone else and they're going to utilize it against me? So this is probably the area that you're going to see going forward, where if we're going to see issues in precision ag, this is probably where you're going to see it. So in terms of the issues, what do we think is going to happen? Where is it going to lead to? So these are kind of what my thoughts and visions are as we see as to where it's going into the future. Number one, as with any other technology, the cost of this stuff is going to drop. Yes, precision ag is expensive, but you look at what a system costs today versus what that system cost 10, 15 years ago, it's significantly less. It's no different than when you look at the first DVD players that came out, or the first Blu-ray players that came out. Some of that technology was pretty expensive. Now you can go down to your local big box store and you can buy a DVD player for, I think, probably $10, $20. So same thing that we're going to see here, that the cost is going to continue to drop. And in doing so, it's going to allow more producers, more farmers, more people to adopt it and make it available and utilize it in their operation. So where will it lead? What's precision ag going to be in the future? And that's kind of where we're going to wrap this up. You could probably start putting some thoughts together yourself as to where it is. And that's going to be your assignment coming up here at the end. The biggest thing here, too, is what impact is this going to have on the future? Precision ag is getting is becoming a greater importance in a typical operation. That's going to have an impact of what's going to go on in the future. That impact is going to be fairly significant in my mind. And the final part is no matter where it ends up, no matter where it's going to lead to, the thing to take away from this is whether you realize it or not, we are all going to be driving it. We're going to be the ones, pushing it from behind, getting it out there, doing more with it. And once again, whether you realize it or not, there's going to be an impact there. So that's kind of the issues. So what we have next is kind of some where we see precision ag at now, where it's going to lead to. So when I first started teaching this class years ago, I would always play this video and say, here's what's coming next. It's a pretty interesting video. It's not something that the manufacturer of this equipment would endorse. And as you can kind of see here when you watch the video, notice there's no operator in the cab, because what's he doing? He's sitting on the side of the field. So go ahead and watch this video. So, as I said, this is kind of a very lighthearted video, but this is now fairly old technology. John Deere came out with this several years ago. It's what's called iTech Pro, where basically you operate in the field. Once he makes a pass around the field, hits a button, and basically from that point on, the tractor and the planter take off and do all the planting for him, which also includes picking up the end of the field, turning it around, and dropping it back in. So, 10 years ago when I started this class, this was, wow, this is really exciting. Now it's kind of like, it's there. So what we have next is, here's some visions of what some people have thought of in the future. Used to be you'd search high and low through the internet, you couldn't find much. Now we can find a lot more. So this is kind of an interesting one of the earlier ones I found, where as you can see on the back of the combine, where it says caution, no driver, big giant satellite dish up on the elevator, an airship moving a hay bale, and then assume a farm kid or farmer sitting there controlling it all with a phone. So, and we have a lot of that now. Driverless vehicles, doing things with your smartphone, not necessarily moving a bale with hydrofoil. So here's some other videos or some other pictures of what we've seen out there. This one I actually picked up from a Pioneer magazine a few years ago. This was kind of one of their artist renditions of what it was. Kind of looks like the inside of a fighter jet or a military jet, where the person running assume maybe a sprayer or something through the field has all this information in front of them, whether it's a yield map or like a radar there on the right hand side. Not sure what that radar is picking up, but a soil map there on the left hand side. So once again, that very high-tech look and feel that we see in the cab. Another one, this has been out for some time. John Deere actually has, as you notice, it's a tractor and it doesn't have a cab. To kind of give you perspective, this thing is about 6 feet tall, so it's not a full-size tractor. They've been utilizing this for years out in California through a lot of the specialized fruit production vineyards, things like that. Once again, very automated system. What you will note there is on the top of it, if you look at that little yellow part, that's the GPS. So the only way that thing is going to operate is it has a GPS. And if you happen to be in Moline, Illinois, down at John Deere's, they have a big pavilion down there where they showcase a lot of their current equipment. They actually have a model of this, or not a model, an actual working model of this sitting there that you can take a look at. Happened to be down there recently, and so these are my pictures from my day excursion to the John Deere pavilion. So once again, this is something John Deere's been doing for quite some time. So I know some John Deere fans are probably pretty happy about that, so the Case folks are probably, what's going on? Well, here is a Case published this years ago in one of their magazines, kind of their vision of what they thought equipment is going forward. And once again, you kind of see that theme of no cab, no operator, a couple radio antennas, which I assume is how it's being controlled. Some other things that we see out there, we're starting to see the utilization of UAVs and drones. And so what we have here, this is actually, once again, it's not up and coming. It's been out there used for quite some time. This is actually over in Asia. You see a lot of this. To give you a perspective, that helicopter is about the size of a four-wheeler, an ATV. So it's a little bit big in size, but it's actually, over their typical fields are 10 to 15 acres. And so this is something that has been utilized for over 10 years over there, where they've been flying fields with these. And once again, these are somewhat autonomous, controlled by GPS, not being controlled by an operator, or not running a remote control. So here's another image of the future, another Case image, kind of a retro design of a quad track. This one actually came out of Kloss a few years back, and once again you kind of notice the theme of a no cab tractor. Here was another one that came out of a Case magazine more recently. This was kind of their take on the future. And if I read this right, knowing Case, that's a 1,000 horsepower tractor. And you can kind of see the technician there, or someone's working on it. There's the support vehicle from Case out there working on it, kind of futuristic. But once again, I'm assuming the black part on the top of the cab is the cab. So you kind of see ladder heading up there. So I assume it's still an operated one, which according to Case now is fairly outdated. So anyway, here's a video I'm going to show you where we kind of see where the future is now. This is a project that Kinsey has been working on, and so when they released this and went public with it a couple years ago, kind of shocked everyone because no one expected Kinsey to be doing something like this. So watch this video because this is the future as we see it happening now. So there you go. So not only are they doing that with the grain carts, but they are also been doing it. They've been working on a model that's basically running a planter, where it's planting a field with no one sitting in the seat, all autonomous. So there's actually been a lot of thought put into it. At this point, it's still not released by Kinsey. They're still actually doing a lot of testing. They're trying to make this system really bulletproof, solid, and good before they release it to the public. So here's another video. This is kind of the shocker that came out recently. As I showed you some of the pictures before where we saw cabless tractors or not a cab there. Case International, Case New Holland introduced this here about a year ago. And it's going to be gaining popularity here very shortly. So watch this one.
We live in a changing world, and farming is changing with it. Our growing population and a greater environmental awareness means farmers need to produce more food, more sustainably, from the same amount of land. It's ultimately technology that will make the difference, and CNH Industrial is at the forefront of this change. we set out to take technology in a different direction that will allow farmers to integrate new technology into existing fleets and give them access to real-time data wherever they are. We believe this technology will, in the future, change the face of farming for the benefit of all. This autonomous tractor concept, conceived by CNH Industrial's innovation team, is truly independent and driverless. It is controlled and monitored remotely, freeing up skilled labor which can be redeployed. It offers the possibility of true 24-hour working, eliminating operator fatigue and enabling a different approach to fieldwork. In the future, an autonomous tractor will make it possible to completely automate grain handling during the harvest. The autonomous tractor and planter can run directly behind a combine, facilitating operator multitasking. A portable interface enables operators to keep an eye on all key parameters and modify them if required, wherever they are. Farmers prize operating flexibility, so with a cabbed autonomous tractor in the farm's fleet, farmers effectively have two machines in one. It can be used to complete tasks which are not yet suitable for automation. And then, when the operator's finished his task, it becomes an autonomous tractor. With CNH Industrial's latest autonomous technology concept, the tractor is able to make its own way to the field along mapped private on-farm paths before it starts to work remotely on its own. We know that modern technology has improved the lives of farmers and farm workers, but at key times of the year, agriculture still demands long hours to bring in the harvest or to get the next crop planted. Autonomous tractors make the most of sometimes short weather windows and can extend the working day to a full 24 hours. A fully interactive interface has been developed to control the autonomous tractors with the immediate and secure recording and transfer of farm data. Farmers are able to use software which automatically plots the most efficient infield paths, use combinations of implement widths, raise or lower the implements, modify implement parameters, and receive real-time views from the tractor's onboard cameras. In less than a minute, the farmer can select a field, a vehicle, and send it on a pre-prepared route. The farmer can continuously monitor the tractor's progress and change parameters as required, but thanks to the flexibility of the technology, they can also use the mobile handheld tablet interface, freeing them up to manage other tasks on site. Weather, of course, has a huge impact on planning and decision-making. Upon receiving a weather alert, farmers can decide remotely where to send machines to complete a task in the best conditions before the next weather event. In the future, autonomous technology will react to weather data and stop automatically when conditions deteriorate, and then start again when they improve. Autonomous tractors can also work in tandem with traditional machines, whose drivers can supervise their activities. Fully autonomous working is also a reality with 2, 3, or even more machines running simultaneously in the same field. It is conceivable that in the future, these autonomous technologies will be extended to encompass a farmer's entire machinery fleet, including combine harvesters, grain transport, and support vehicles. Autonomous technology also provides advanced obstacle detection. The tractor is able to detect obstacles through a combination of infrared, radar, and LiDAR, which uses range-finding lasers. When the tractor encounters an obstacle, the farmer is alerted through the tablet interface. He can then tell the tractor to avoid the obstacle by remotely approving an automatically generated alternative path around it. Alternatively, He can instruct the tractor to drive straight over an obstacle. The tractor's intelligent obstacle detection system can also tell when an obstacle crosses its path and will bring itself to a stop. Once the obstacle is cleared, it'll continue on its route. Manual path plotting is also possible when refueling or when custom paths are required. CNH Industrial enjoys a historic working relationship with its technology provider, Autonomous Solutions. ASI has global experience in autonomous technology across the agricultural, automotive, and mining industries. Together, we are leading the way in bringing this technology into agriculture. Of course, this isn't the first time that CNH Industrial's agricultural equipment brands have led the way. For more than 170 years, we've been at the forefront of developing advances in agricultural machinery. And we're the first manufacturer to factory-fit precision farming technologies. Since then, we've continued to invest in these technologies, helping farmers to monitor yields, automatically alter fertilizer rates based on prescription maps, and develop precision in-field guidance paths. And now, once again, CNH Industrial is leading the field in the development of cutting-edge farming technology concepts. Our concept of autonomous tractors will do far more than simply go out and work. In the future, they'll offer farmers total control of the vital data that will allow them to make the informed decisions necessary to boost productivity and overall efficiency. Better still, this is not an all-or-nothing approach. Our autonomous tractors could be seamlessly added and integrated into existing fleets. The autonomous tractor concept from CNH Industrial provides a tantalizing glimpse into the future, when the interface with big data will provide connected farmers with not just the machinery needed to work the land, but also the help they need to make their most critical business decisions. The autonomous tractor concept from CNH Industrial.
So, what do you think of that? And to wrap it up, we've been doing a lot on Case. Here's kind of a video that came out a few years ago from John Deere, and you can search this out on YouTube. It's called Farm Forward, and John Deere actually put this out now. It's been out now for 5 or 6 years maybe. You take a look at this, and even when they produced this video and announced it, they were already working on some of these technologies. Take a look at this and see what you think.
Good morning, Terry. Main menu. Weather. Welcome to John Deere Farm Site. Field order. Please prioritize. Work order. Confirmed. Alert. Irrigation. Irrigation system initiated. Incoming call.
Hi, Terry. We're finishing up your planter service. It'll be ready today.
Thanks, Sean. I really appreciate it.
You got it.
Message from Crop Advisor. New prescription transferred. Alert. Weather. Alert. Weather. Changing seed population. Files sent. Alert. Row crop tractor 14 has stopped. Message. Dealer technician ETA 32 minutes.
So how was that? That one is kind of cool, I got to admit. And I'm a John Deere person at heart, but I still like what Case and what everyone else does. But it's interesting to see that John Deere has been doing that and already working towards that. So be interesting if it does come to fruition. And to top it off, I have one last video. This one is kind of interesting. It's basically in terms of where we see the future. So I actually got to see the working model of this about a year ago at a conference. It's a pretty interesting system, and could be an alternative to, instead of buying a big expensive planter, you buy a bunch of these and just turn them loose on the field. So enjoy.
Food, man's most basic need. Throughout the ages, men have strived to produce more and better food for growing populations. More land, better tools, improved techniques, and technological advances. However, all this progress has had one common element that has not changed: man. Man has always been at the center of food production and has now become the limiting factor. For 10,000 years, the primary focus of technological advancement has always been increasing the productivity and safety of the operator. But these incremental improvements will soon be outpaced by the exponential population increase that we are experiencing. Sometime in the near future, the population will exceed our ability to provide food for all of Earth's inhabitants. What we need is a paradigm shift on a scale of the transition from hunting and gathering to an agrarian society. A complete reboot that will change our conception of what agriculture is. Inspired by nature, utilizing swarm and gaming theory, they will plant, tend, and harvest, executing each agricultural task and reducing the need for herbicide, insecticide, tillers, planters, and harvesters. This new system will be developed in 4 phases. Phase 1, planter. Phase 2, tender. Phase 3, harvester. Phase 4, integration of the planting, tending, and harvesting into one autonomous intelligent robot that can operate all season long, performing any task as necessary. Prospero is a working prototype of Phase 1, a swarm of autonomous microplanters. Operating as one organism to plant a field, they determine where and how to plant each seed to maximize the productivity of each acre, farming inch by inch. First, they check the ground below to see if a seed has already been planted and whether proper seed spacing has been achieved. If not, they will plant a seed at the optimal depth. Then they mark the seed's location and apply any necessary fertilizers, herbicides, or insecticides. It communicates wirelessly with the rest of the swarm to optimize the swarm's planting efficiency, letting nearby robots know if it needs help planting in that area. Prospero does all this now.
So what'd you think of that? I think that's pretty cool. Imagine you could just program in 100 of these and they're just going to take off through your field and go plant your field. And you don't even have to worry about it. So anyway, the future going forward, still a lot of unknowns, still a lot of big question marks, but precision ag is going to definitely be a big part of it. So if you got to Blackboard, I've got a couple assignments for you to do. So the first thing I want you to do, write a 1.5 to 2 page paper. What I want this paper to be is a vision of what precision ag is your vision. What do you think precision ag is, and what its future will be? So kind of put it out on paper. Where do you think precision ag will be? And I'll leave it up to you, whether you think it's in the next 5 years or 10 years, 20 years, whatever it is. Take a look at that. Paper has to be, 1-inch margins, double-spaced, 10-point or 11-point font, typed up, and then upload the completed paper up to Blackboard. You'll see there's a drop box up there where you can load that up there. So that's the first part. The second part, what I want you to do is also on a separate piece of paper. I'm not looking for artistic skills, but I want you to kind of draw out, sketch out what you think that future will be like. So take a look at what you put in your paper and kind of put it to, make a vision of it, or an image. And I don't care if it's stick figures, because I myself, I don't have any sort of artistic skills. My sister got all of those, by the way. So it can even be stick figures. I'm not going to grade you on your artistic abilities. I want to grade you on, what your vision is and what you think it is. So you can draw it out, take a picture with your phone, and submit it up, as a graphic image, or however, graphic image is the best way to do that. Then the last thing I want you to do This was going ahead 50 years. So this came out in 2013. It's a handout. It's out there on Blackboard, but basically it's a glimpse at what's going on in 2016. It's the average day of a typical person. So with ag technology being involved. So take a look at that, and then this will conclude the unit. Enjoy.